Hello and welcome back to this A-level OCR paper. So this one is on trig and it's about taking a combination of trig functions and writing it in a specific form. So we want to write as r sine x minus alpha. Now in the formula book you have the double angle, sorry not the double angle, the addition formulae. So what we see is that if we want to do sine of x minus alpha, this is going to be r sine x cos alpha minus r cos x sine alpha. And we want this to equal 3 sine x minus 4 cos x. So to get the r is quite straightforward. You just do the numbers in front. It's kind of the length, so it's Pythagoras. 3 squared plus 4 squared, which is just 5. Now to get the angle alpha is a little bit trickier. You need to compare coefficients here. So if I look at the first term and compare it to what I've got here, so if I look at these two, I can see that 3 is going to have to equal r cos alpha. So r cos alpha is 3. And if I look at the second term, I'll do this in a different colour, I can see that if, by comparing, r sine alpha is going to have to equal 4. Okay, if I do the r sine alpha equals 4 divided by r cos alpha equals 3, what I'm going to end up with is that tan alpha is 4/3. And if tan alpha is 4/3, I can work out alpha by doing tan inverse of 4/3. And when I put this into my calculator, making sure I'm in degrees mode, I get 53.13. Looking back at the question, it wanted 4 significant figures, so that's what we'll do. 53.13 degrees. Now, we've only got 2 marks at the moment. To get the last mark, we need to write it in the form that it's asked us. So therefore, 3 sine x minus 4 cos x equals, r was 5 sine x minus 53.13 degrees. And that is our final answer there. Okay, on to part B. So in part A, we saw that we had 5 sine of x minus 53.13 degrees. And in part B, we want to solve 3 sine x minus 4 cos x equals 2. Now what you'll notice, this is exactly the same as this. So we can just set this equal to 2 straight away. Now, how do we solve a trig equation like this? Well, we need to divide by 5 first to get 2/5. Then, to get this bit in brackets on its own, so to get this bit, we are going to take the sine inverse. So x minus 53.13 degrees equals sine inverse of 2/5. So x minus 53.13 degrees equals, and then sine inverse of 2/5, which is 0.4. That is going to give us, oh, I didn't do sine inverse, whoopsies. There we go, 0.4. And that gives us 23.58. Now, thinking about the solutions to sine, we draw the graph dead quickly. This is the graph of sine. So I've just shown there's a solution here to 0.4, which means there's another one here. Okay, so if I subtract from 180, my answer, I will get another solution. And that gives me 156.4. Well, let's do 2 decimal places, 156.42. Okay, so now to get x on its own, I need to add 53.13 to each of these. So let's see what that gives us. So we've got 23.58 plus 53.13. So my first solution is going to be 76.7 to 3 significant figures. And my second one is going to be 156. So 156.42 plus my 53.13. And we get 209.55. Now, just looking back at the question, we wanted 0 to 90. So I don't need this one at all. And in fact, this is my only answer. Okay, hope this helped.